All right, sixth graders, this is to help you with question 6 on CR number 7, version B. It says, Gordon wants to buy caterpillars to feed his box turtle. He can buy 6 caterpillars for 3 dimes. Then it asks, how many caterpillars can he buy with 9 dimes? Okay, he can buy 6 with 3 dimes. So let's say we have another 3 dimes. He could buy 6 more caterpillars. My caterpillars are not going to look like the nicely drawn ones. Let's just pretend these are caterpillars. All right, and we want to know how many caterpillars for 9 dimes, where every 3 caterpillars is 6, or I'm sorry, every 3 dimes is 6 caterpillars. So I drew 3 more dimes and 6 more caterpillars. To get up to 9 dimes, I'd have to draw 3 more dimes. Then I get 1, 2, 3, 4, 5, 6 caterpillars. More than one way to look at this. I can now see with 1, 2, 3, 4, 5, 6, 7, 8, 9 dimes, I can get 2, 4, 6, 8, 10, 12, 14, 16, 18 caterpillars. So he can get 18 caterpillars for 9 dimes. Let me just show you another way you could handle that. You could consider a ratio of dimes to caterpillars. And you know 3 dimes was 6 caterpillars. And now we're saying if I want to spend 9 dimes, how many caterpillars will that be? And I know you're working with some equivalent fractions right now in class. So you have to say, how do I get from 3 to 9? Oh, 3 times 3 is 9. So then I could say, how do I get my new denominator? Well, if I'm multiplying my numerator by 3, I have to multiply my original denominator by 3 so that the fractions become equivalent. 6 times 3 is 18. So that tells me for 9 dimes, I can get 18 caterpillars. And I know that these are equivalent because 3 out of 6 is 1/2, and 9 out of 18 is 1/2. All right, so 18 caterpillars. You can either just draw out the picture or make a ratio and create equivalent fractions. Today, the cost of caterpillars went down. He can buy 5 caterpillars for 2 dimes. How many can he buy with $2? Okay, whew. All right. 5 caterpillars now for 2 dimes. So it's a new day, and the cost actually for caterpillars went down. He now only has to spend 2 dimes to get 5 caterpillars. All right. So for today, visually, it would look like 2 dimes, so you don't have to use the 3rd dime. 2 dimes for 1, 2, 3, 4, 5 caterpillars. All right, so that's the visual, 2 dimes for 5 caterpillars. How many can he buy with $2? All right, well, how many dimes are in $2? That's what I first have to figure out. So in $2, how many dimes? $2 is how many dimes? Well, hopefully you know in $1, it takes 10 dimes to make $1. So if it takes 10 dimes to make $1, you know, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 cents took us 10 dimes to get to $1. So then to get to $2, you'll actually need 20 dimes. All right, so I know 5 caterpillars for 2 dimes. Okay, so again, I could set up my dimes to caterpillars if I wanted to, or I could draw myself a picture. 2 dimes today will get me 5 caterpillars. I want to know how many caterpillars I can get for $2, and we just determined that $2 was 20 dimes. So if 2 dimes gets me 5 caterpillars, 20 dimes will get me how many caterpillars? And we could figure that out. How do you get from 2 to 20? Oh, 2 times 10 is 20. So if I'm multiplying my original numerator by 10, I better multiply my original denominator by 10 so that I can create an equivalent fraction. 2 to 5 is the same as 22. 5 times 10 is 50. So he can actually buy 50 caterpillars. And you could choose to draw your visual. You could do 2 dimes, 5 caterpillars. 2 more dimes, 5 more caterpillars. 2 more dimes, 5 more caterpillars. And then you eventually realize that it took 20 dimes would get you 50 caterpillars. So you could draw it out. You could set up a ratio. I could think about doing a table. I hope that is enough to support you on this problem. Good luck.